Good morning. We're going to be doing one of the questions that was given in the May-June 2025 question paper 13. This is question 1, and it is a differentiation question. We'll just be showing you how to answer this, just in case you didn't understand it. So they gave us the curve equation, which is 2x plus 12 over x squared. Find the equation of the tangent to the curve at point -2, -1. Give your answer in the form y equals mx. So they basically want us to find a line equation for the tangent. This is easy because all we have to do is basically we have to find dy over dx, and then we find the gradient. The gradient of the tangent is equals to the gradient of the curve. So basically the point at which the curve and the tangent intersect is they all have the same gradient. Once we find the m value, we can plug in the coordinates that they gave us, which is -2 and -1, into this formula, which is y minus y1 equals to m brackets x minus x1, and we can form a equation in the form of y equals mx plus c. So let's start. First of all, we have to differentiate 2x plus 12. Wait, sorry, apologize, just give me 1 second. Yeah, so we have to differentiate this, which is the curve equation, and this is basically very simple, to be fair. This is free form works. So the first thing you have to do is the first thing that you can do, actually, in my opinion, this is what I normally do, is when we have a fraction, we just take the denominator up, we take the denominator above. Basically, we put it together with the numerator. So if we take the x squared up, all that happens is basically it becomes negative. So it becomes x minus 2. Now it becomes much easier to differentiate because you have the powers of x here, and you don't have to deal with like denominator stuff. So we have everything in one line, and it's much easier. So how you're gonna differentiate this? When you're differentiating, you remove the x values, and basically x decreases by 1, and all you have to do is multiply the power of x minus 1, multiply by the coefficient, multiply by the power. So here we have the coefficient of 2, and here we have the power of 1. They don't mention 1, but that's all. Normally that's all you have to remember. So 1 multiplied by 2 is 2. X changes from 1 to x equal to 0, which is x equal to 0 is equals to 1. So we don't need to write anything. The answer is 2. Next, we multiply minus 2 with 12, which gives us minus 24. X and also x decreases by the power of x decreases by 1, which becomes x minus 3. Now this is the dy over dx that we have. Dy by dx that we have. Now what we can do is basically we can plug in the x values that they gave us. So the coordinates that they gave us is -2, -1. This is the x values. We can plug in the x values here and find the gradient of the curve at that point, which is -2, 24, -2, actually plus 2, -24, brackets -2 to the power of -3. Now we can plug this in. Wait, just give me a second. -2, -24, -2 to the power of -3, and the answer is 5. So the gradient of the curve at that point is 5. Now all we have to do now is basically plug into this equation, which we have mentioned earlier, which is y minus the y coordinate that they gave us is -1. So we plug in -1 equals to the gradient of the curve, which is equal to the gradient of the tangent as well, and we plug it in. So 5 multiplied by x this is a constant minus the x value that they gave us in the question, which is -2, and we just plug it in. So you end up with an equation of y plus 1 equals to 5x plus 2. Once you simplify this even further and you expand the brackets, you end up with 5x plus 10 equals to y plus 1. Now what you can do is basically you can equate this to y and get 5x plus 9, because 10 minus 1 is going to be 9, and this is going to be your answer. So this is how you solve question number 1 from May June 2025, question paper 13. Thank you.